Hey guys, Mrs. Jockel back to teach our next math lesson for this week. We are on lesson 12.7 and today we're going to talk about triangles. You see Sadie right here? Her reflection in my china cabinet. She's on the computer doing some math practice of her own. All right guys, so grab your math books and open them up to lesson 12.7. Describing triangles. Now this first page, I'm just going to kind of skim through it. It's a hands-on activity that asks us to use different length straws to try to put together different kinds of triangles. So they wanted you to cut some straws into different lengths, find some straw pieces that you can put together to make a triangle, and then kind of see what you observe about that. If you look at the pictures here of the girl who's trying to make some triangles of her own, in the first picture, she has the green, blue, and the orange straw, and you can see how those pieces all seem to be different lengths. The green seems to be just slightly shorter than the blue, but not by much, and then the orange piece is a little bit longer. And she's able to connect those three lengths of straws to create a triangle. And then in the second picture, though, it looks like she's having a little bit of trouble trying to put those straws to make a triangle because two of the straws are really short and she has one really long straw. And so when you think about that, if you have two short sides to a triangle, it's going to be very hard to connect all three sides together. And so it wanted you to compare the lengths of the sides and describe when you can make a triangle, and then to describe when you cannot make a triangle. And then on number 3, how can you change the straw pieces to make a triangle? I'm not really going to focus a whole lot of time on those questions because my focus today is more on teaching you the types of triangles that do exist based on either the side lengths or the types of angles they have. So what's most important is to understand triangles have 3 sides, they have to be straight, and they have to connect, they have to be closed. So don't worry about really writing anything for 1, 2, and 3. We are just going to kind of cruise over to the next page here. And it says, ways to describe triangles. What are 2 ways triangles can be described? So they drew 5 different triangles for us, A, B, C, D, and E. And if we look at these triangles, we could try to classify them by the lengths of their sides, okay? And I'm going to teach you guys a little bit extra than what our book does because there are specific names for certain types of triangles. So if we look at triangle A, the orange triangle, what do you notice about all of the sides for triangle A? Would you say that no sides are equal, 2 sides are equal, or 3 sides are equal in length? And if you are looking carefully, and what I like to tell my students is, pretend like one side of the triangle is collapsing. And is it going to lie flat and the same length as the side that it falls on? And so if you kind of imagine doing that with triangle A, if you collapse the sides that are diagonal and collapse them down on the bottom, you should be able to see that they in fact are about all the same size. So triangle A, we're going to connect to the last dot because all 3 sides are equal in length. Now, there's a very special term for this kind of triangle, and I have that pictured over here on the left-hand side of the screen. When all sides of a triangle are equal, we call that an equilateral triangle. It almost has the word equal in it, just spelled a little differently. But an equilateral triangle has all equal sides. So all 3 sides would measure the same length. Pretty simple and easy to remember. Let's look at the next way we can classify triangles by their side lengths. If we look at triangles B and E, what can you notice about the side lengths of those triangles? I think it's a little easier to see on triangle E. Triangle E always reminds me of like a TP because the two sides coming down of the triangle are the same length, and then you can see there's a short side across the bottom. Triangle B also has two sides that are the same length, but it's the side that's going vertical and then the side that's going horizontal. Those are the same length. And then I'll trace over the ones on triangle E that I was talking about coming down, like forming that TP. And so triangles can be identified if they have two sides that are equal in length. So we're going to just draw a straight line down to connect those definitions. And there is a term for triangles that have two sides that are equal in length. And that is, sorry, Mrs. Van Wert's calling. That is called an isosceles triangle. So an isosceles triangle, I have it over on the left-hand side. An isosceles triangle is what we call those triangles that have two sides that are equal in length. And I tried to come up with a way to kind of remember this. If you look at the word isosceles, it has two pairs of letters where two letters are the same. The SOS, so the two S's represent the two sides of the triangle that are the same, and then the O represents the third side that is a different length. And then there's another pair, ELE. The two E's represent the two sides that are the same length, same letter. And then the L would represent the third side that is a different length. That is just a weird, I know, kind of odd trick that helps me kind of remember that isosceles triangles have two sides that are equal in length because there's a pair of two letters that are the same with a third letter that doesn't belong. So if that makes sense to you, that might be a helpful hint as to how to remember the term isosceles. And then when we look at triangles C and D, triangles C and D, I'm in a different color here. When we look at the side lengths of C and D, and if you do that collapsing like I talked about, you know, pretend like you're cutting down one side and it's timber. None of the sides of those triangles are the same for C and D. They all have different lengths. So we're going to connect that to the first definition. No sides are equal in length. And there is another term for that that our book does not teach us, but that term is scalene. So if you come over to the side, the left side with me, and we look at the term scalene, scalene triangles have no equal sides. None of the sides are the same. So I was trying to figure out, you know, what's a little hint for that. You know, I think one big word I see in the word scalene is the word scale. And it reminds me that, you know, lizards and fish and snakes have scales, and they come in many different shapes and sizes, those creatures. So no equal sides because there's many different species of, I don't know, reptiles that come in different shapes and sizes. I don't know. It's a stretch, but I'm always looking for little tips to try to remember things. But I think if you can remember equilateral, triangles have all equal sides, and then isosceles triangles have two equal sides, then scalene is just the leftover. It's the triangle that has nothing, none of the sides are the same. So I don't know if that helps or not. And again, these are just extra math terms that our book does not use, but terms that you'll eventually be learning and hearing maybe next year in fourth grade, so you'll already kind of have a head start and be familiar with those terms. So another way we can classify triangles besides looking at the lengths of their sides is to look at the types of angles that they have. Now we know triangles, they have 3 angles. That's why they're called triangles. And if we have a triangle, look, such as letter C down here at the bottom, and you look at the one angle here, it is opening up greater than 90 degrees. It has an obtuse angle. So when one angle is greater than 90 degrees, you could call it an obtuse triangle. Now notice though what about the other two angles. If one angle is obtuse, the other two angles have to be acute, because when you have one angle of a triangle opening up very wide, the other two, in order to close the triangle, have to be pinching in. They have to be acute or less than 90 degrees. So if we look at triangles A and E, looking at the angles now, not the sides, but when we look at the angles of A, oops, I did that. This top angle, maybe I need to draw two separate lines. There we go. These angles are what kind of angles? They are pinching in, they are less than 90 degrees, and so we would call them acute. And notice how all three angles are less than 90 degrees. All three are acute. So what kind of triangle do you think you would call this? An acute triangle, because all of the angles are acute, okay? And then the easiest triangle to remember, I think, based on the angles, is a triangle that has this perfect, just right, there it goes again, this perfect, just right angle. You notice how it has that square corner, telling us that this is a perfect right angle. And so when a triangle has one right angle, as you can see on my left-hand side, we call it a right triangle. It's just right. It has a perfect right angle. So triangles can be identified based on the lengths of their sides, either all equal, only two equal, or no equal sides. Or triangles can be identified based on their angles. One obtuse angle gives us an obtuse triangle. Three acute angles. When all the angles are acute, we have an acute triangle. And when we have one right angle in our triangle, we have a right triangle. Simple as that. All right, so moving on to the next page, the share and show. We need to write the number of sides of equal length the triangle appears to have. Now, if you're having a hard time looking at the sides of the triangle to see if they're equal or not, like I said, try to do the collapsing of one side on top of another and see if you think they would match up. Or you could always get a piece of paper, thin white paper, and try to trace one of the sides and then line it up on top of the other. Or grab a ruler. Measuring the lengths of the sides is also a beneficial way to see if the sides are equal or not. What I can do is I can trace the sides as best as I can, and then what I was saying with the kind of collapsing, if I try to turn it, hey Noah, and see how those two sides match up pretty well. But if I turn it some more to match on the side here, we can clearly see it doesn't match. So for this triangle, it has two sides that are equal in length. Two sides that are equal, and that would be an isosceles triangle if you wanted to start practicing that terminology, because two sides are the same. Okay? All right. Using triangles F, G, and H for questions 2, 3, and 4, which triangle has one right angle? One right angle. Well, remember, right angle, we're looking for that perfect corner. So triangle F has that perfect right angle in the corner. Which triangle has one angle greater than a right angle? So we're looking for an angle that is greater than 90 degrees or obtuse. When we look at triangle G, all of these angles are pinching in. They are less than 90 degrees. But triangle H over here has this angle that's opening up pretty wide, and then the other two are obtuse. So triangle H has that obtuse angle opening up greater. And then which triangle has three angles less than a right angle? The three acute angles we just saw, that would be triangle G. All right, on your own, using these triangles, same type of thing, filling in the blanks, which triangle matches the clues. Let's look at number 5. Triangle blank has one right angle and appears to have how many sides of equal length? Okay, so the clue here is a right angle. Hi, Sadie. Can you go? And so I see that right angle in triangle M. And then we need to look at the sides. How many sides of triangle M appear to be the same length? Tilt your head a little bit. I'm thinking that 2 sides appear to be the same length. So the side that's coming straight down and the side going across the top appear to be the same length. So it has 2 sides of equal length. So this triangle, we could call it a right triangle because it has that right angle, or because it has 2 sides of equal length, it is an isosceles triangle. So we could actually call it either one of those. And again, that's just a little extra, but you know me, I like to do a little extra with you. Okay, number 6, which triangle has 3 angles less than a right angle? 3 angles less than a right angle. So all 3 need to be pinching in. And I see triangle K has all acute angles. And how many sides of triangle K appear to be the same? Looking at all the sides, all 3 of them are the same length. So we could call this triangle an acute triangle, or because it has all equal sides, it is an equilateral triangle. Oops, I forgot the U. Okay, so it has 2 different names also, one based on the angles it has and the other name based on its sides. And number 7, which triangle has one angle greater than a right angle? So that would have to be triangle L. It has this angle here opening up very wide. So triangle L has an angle greater or obtuse. And how many sides appear to be the same? Looking at all the sides, imagining them collapsing, 0. None of them would be the same. So that means we would call this an obtuse triangle or a scalene triangle because none of the sides are the same length. Okay? All right. Over to our problem-solving page here, and I have the triangles over on the left-hand side just as a reminder throughout the lesson about those new terms that I was teaching. But let's take a look at number 8, making sense of the problem. Martin said a triangle can have 2 sides that are parallel. Does his statement make sense? So what Martin is saying, a triangle can have 2 sides that are parallel. Do we remember what parallel means, boys and girls? Even if I draw them at different lengths, parallel means that the 2 sides would never cross or touch. They are directly opposite of one another. Now that I have some parallel lines here, can we make a triangle? The answer is no, because in order to make a triangle, we can only have 3 sides. How could I possibly keep these 2 lines parallel and close up my shape to make it a triangle? As soon as I add a 3rd side at the top, I have an open shape. It's an open plane figure. This is not even a polygon, boys and girls. And when I close my shape up, I have to add a 4th line segment. And now this is not a triangle, instead a quadrilateral, specifically a trapezoid for the one I drew. So no, Martin cannot have a triangle with parallel sides because you would never be able to close the triangle. Okay, does this make sense? No. Short answer, no. But of course, we always have to explain why this doesn't make sense. Okay, so a triangle has 3 sides, and you would need 4 sides to make the shape closed. Something along those lines. You know, you could say a triangle has 3 sides, so it would be open. It wouldn't be closed if you added a 3rd side to your parallel lines. Basically, he can't make a triangle that has parallel sides. All right, number 9, go deeper. Compare triangles R and S. How are they alike? How are they different? Okay, so when we think of how these triangles are alike, we're looking for what is the same about them. So that means we want to look at the side lengths that they have or their angles. I can tell that triangle R looks to have all 3 sides equal, but triangle S does not. You see that? Triangle S is more of the TP on its side. It has 2 sides that are equal in length and 1 side that is shorter. So their side lengths are not the same. Let's look at their angles. What do you notice about all of the angles within those 2 triangles? I am noticing that all of the angles are acute. So we could say both have 3 acute angles. And then how are they different? Okay, well, triangle R, as I mentioned, has all equal sides, and triangle S only has 2 equal sides. Nice, Sadie. Sadie's playing with some silly putty. Okay, so both have 3 acute angles. So triangle R has all equal sides, but triangle S only has 2 equal sides. Okay? So that's how they are alike, but also different. They have the same type of angles, but their side lengths are different. All right, think smarter. Using a ruler to draw a straight line from one corner of this rectangle to the opposite corner. You don't necessarily need a ruler. You could use the edge of a piece of paper or just do your absolute very best to make a diagonal line from corner to corner. What shapes did you make, and what do you notice about the shapes? So what shapes do you see now that we have split this rectangle diagonally? So I'm going to trace over one shape with my red pen. So what did we make? Okay, we made 2 triangles. Okay, what do we notice about those triangles? Because it says, what do you notice about the shapes? So we made 2 triangles. The triangles actually are exactly the same if we were to lay them on top of one another. They're just kind of turned differently right now. So we made 2 triangles that are the same and both have a right angle. right? Both triangles have a right angle. Whoops. This top corner here is a right angle, and then the bottom corner of that triangle is a right angle. So they both have one right angle. All right, cool. Number 11, write the name of each triangle where it belongs in the table. Some triangles might belong in both parts of the table. Some triangles might not belong in either. Okay, so we need to sort these triangles into these two columns. Either has one right angle or has at least two sides of equal length. So I think let's go through and find the ones that have a right angle first. So what triangles do you see with a right angle? Hint, hint, look for the square. So I see triangle N, triangle P, L, and R. N, P, L, and R, any particular order, doesn't matter. Those four triangles have one right angle. And again, I knew that real quick because it had that little square corner telling me that it was a right angle. Now the harder part is going to be looking for the triangles that have at least two equal sides. So we're looking for triangles that have two equal sides or all three sides equal. And so for that, let's go with letter J. Letter J looks to be equilateral, all equal sides. Okay. How about N? N up there, looking at how those sides collapse. If you chop down the diagonal one, I don't think it's going to match up. So not N. K does not look like it has equal sides either. That's scalene. Q does. Q looks to be an equilateral triangle like J. How about letter P? Triangle P, even though it has a right corner, a right angle, the two line segments that make up that right angle appear to be the same length. So I'm going with P. What else? M does not look to have any equal sides. L, no, I don't even think L. Even though it has a right angle, if that top one collapses down, it's going to be too long. I like R though. R looks like it has a right angle. And O is like my TP triangle. The two sides coming down appear to be equal. So J, Q, P, R, and O. And I have the answer key, and we're correct. All right, so letter M and K didn't belong anywhere because those two triangles were scalene, so none of the sides were equal, and they don't have right angles. So those two were the oddballs. All right, guys, nice work so far. Hopefully you're getting the hang of all these triangles here. We're already to the practice and homework page, so let's get this done. All right, so using A, B, and C, those triangles to fill in for 1, 2, and 3, although they did one for us. Triangle B has 3 angles less than a right angle, so that would be an acute triangle, and then 3 sides of equal length. So it's an acute or equilateral. Number 2, which triangle has one right angle and appears to have how many sides equal? Okay, I love when it asks about a right angle because I'm looking for this perfect corner. So I know triangle C has that right angle, so it is a right triangle. And how many sides appear to be equal? Well, none of them appear to be equal to me. It doesn't seem to have any sides that are the same length. So this would be a scalene triangle because no equal sides. Scalene. All right, and then triangle A must be the one that has an angle greater than a right angle, and I see that here in the corner. That angle is opening up, so that's our obtuse triangle. And how many sides appear to be the same in triangle A? Let me erase my marks that I made here. Okay, what do we see? What do we see? It's kind of tricky, but the bottom side and then the right side, you can kind of see now that I traced them in color and I'm like moving my head back and forth, those two are the same length. So triangle A would also be an isosceles triangle because it has two sides that are equal. Right, problem solving. Matthew drew the back of his tent. How many sides appear to be of equal length? Okay, well, I love tents, or I was calling them teepees earlier, because the two sides coming down for the opening are the same in length. So this triangle has two sides that are equal, and so just as a little extra bonus, we would call this an isosceles triangle. Okay, because it has two sides that are equal. Number 5, Sierra made the triangular picture frame shown. How many angles are greater than a right angle? How many angles are greater than a right angle? So if we look at these angles here, wasn't a very good trace job. Are any of those greater? None of them. So 0 angles are greater than a right angle. In fact, all of them are acute. So this would be an acute triangle. Okay. Number 6, draw a triangle that has two sides of equal length, so isosceles, and one right angle. Now I can cheat a little bit because I have triangle shapes on the Smart Notebook software here. But the trick is, there we go. So here we go. This is a triangle, and you can try to draw the same one as me. It doesn't have to be perfect, but there's the right angle. And the two sides that are equal in length would be my vertical side coming down, and then my horizontal line segment going across. So this triangle would be isosceles because it has two equal sides, but also a right triangle. All right, cruising on to the last page here, lesson check. How many angles less than a right angle does this triangle have? So remember, less than a right, it's so teeny tiny, it's pinching in. Acute, how many do you see? I see 3 acute angles. Okay. Number 2, how many sides of equal length does this triangle appear to have? How many sides of equal length? So, just to test this out a little bit, if we took and traced this side, okay, a little crooked, but it'll do. And then what am I doing here? Let's clone it. And now I need to turn it, although it's moving. I didn't want that to happen. But I think we can see that it matched up. And then let's clone it again. And what is this? Flip it. I don't know what that did. Okay. Let's see if we now turn it. No. It's gonna be a little short. And I know it kind of shrunk a little as I moved it, but you get what I'm kind of going for here, guys. This is hard to do on the computer. I'm seeing just two sides that are equal. Okay, two sides that are equal, so this would be an isosceles triangle. And it's nice, I can always look at the answer key if it's hard to tell. All right, so we've got an isosceles triangle. All right, number 3, spiral review. A quadrilateral has 4 right angles, 2 pairs of sides of equal length, and 2 pairs of opposite sides that are parallel. The pairs of opposite sides are not the same length. What could this triangle or quadrilateral be? Okay, that is kind of confusing to me. So let's look at this again. It has 4 right angles. So a shape that has 4 right angles has to be a square or a rectangle. It has 2 pairs of sides of equal length. So 2 pairs of sides that are equal. It could still be a square or a rectangle, even though a square has all 4 equal sides. And the opposite sides are parallel. Okay, so the opposite sides are never going to cross or touch, so we're still looking at a square or a rectangle. Here's the important part. The pairs of opposite sides are not the same length. Okay, so because the pairs of opposite sides are not the same length, then we are looking at this shape. And what do we call that shape? A rectangle. So sometimes the words are confusing in a problem, and like I've said multiple times, we try to just get rid of the fluff, get rid of it, the extra words, or highlight important words, or just read the problem another time. All right, number 4, Mason drew a quadrilateral with only 1 pair of opposite sides that are parallel. Only 1 side of opposite sides that are parallel. What did he draw? Well, I'm trying to find something I can use here because I know what I need. I need this shape here because when we look at this shape, it only has the top and the bottom segments are parallel. So what do we call that shape? A trapezoid. Okay. And number 5, draw a rectangle that has an area of 8 square units and a perimeter of 12 square units. What are the side lengths of the rectangle? Okay, so this is a little tricky because we skipped over the chapter of perimeter and area, but first, let's just walk through it. Draw a rectangle. There we go. And we need it to have an area of 8 square units, meaning we need to have 8 squares drawn inside the triangle. Okay, area is the space inside. And the perimeter needs to be 12. So that means when we add up all the sides, we need to have a total of 12. So I'm first going to just split my rectangle horizontally in half. So this really gives me an area, technically, I guess, of 2, if you really count that. And then let's split it vertically down the middle. And then each of those sides we need to split in half again. So something like this. And we're going to see if this works. So an area of 8. Do we have 8 boxes inside? 1, 2, 3, 4, 5, 6, 7, 8. Yes. And then the perimeter has to equal 12. Meaning when we count these individual segments going around the top, bottom, and the sides, it should equal 12. So that's 4, and then down the side is 5, 6, 7, 8, 9, 10, 11, 12. So that rectangle would work. What are the side lengths of the rectangle? So we've got 2 units and 4 units. So the top and bottom are 4 units in measurement, and then the 2 sides are 2 units. If that was a little tricky or confusing, don't stress too much because we'll come back to chapter 11 that had perimeter and area. Number 6, though, we should know with fractions, what fraction of the square is shaded? So how many parts are shaded? 1, 2, 3. And the denominator needs to be the total number of parts for the shape. So if there's 3 shaded, 4, 5, 6, 7, 8. 8 total. So our fraction is 3/8. All right, guys, so the math lesson is over for today, but as an extra little bonus here, I have our math antics friend who's going to teach us a little bit more about triangles and review what we learned today. You don't have to watch this video if you don't want to. You can just close out of it right now. But I know I always learn best from seeing things more than once. And so if you're hanging out a little longer with me, thanks for tuning in. And here is a video that goes along with our lesson for today.
Hi, welcome to Math Antics. In this geometry lesson, we're going to learn all about triangles. You may remember from the lesson about polygons that triangles are special polygons that always have 3 sides and 3 angles. And that's what the word triangle means. Tri means 3, and angles means angles. Okay, that's easy enough. 3 sides, 3 angles. But what else is there to know about triangles? Well, for starters, we're going to learn how to classify triangles. Ooh, such a classy triangle. But seriously, there's 2 different ways to classify or organize triangles. They can be classified by their sides, and they can be classified by their angles. Let's start by classifying triangles by their angles, since we've already learned a lot about angles in the previous videos. You may remember from our first video about angles that there's 3 types of angles. There's right angles, acute angles, and obtuse angles. Well, watch what happens if we use a third line in each of these angles to form closed shapes. Aha! Triangles. And can you guess what these 3 different kinds of triangles are called? Yep. The one made from the right angle is called a right triangle. The one made from the acute angle is called an acute triangle. And the one made from the obtuse angle is called an obtuse triangle. So that's simple enough. But notice that for each of our 3 triangles, the new angles that were formed when we closed the shapes are all acute angles. So triangles always have at least 2 acute angles. And it's the other angle that determines what type it is. That's important to know so you don't get tricked. For any given triangle, just because you see one acute angle, that doesn't mean it's an acute triangle. You have to look at all the angles to tell if it's an acute triangle. The situation's easier with right and obtuse triangles because you can only have one right or obtuse angle per triangle. So as soon as you spot one of those kinds of angles, you know what type of triangle you have. All right then, classifying triangles by angles is pretty simple, but we can also classify triangles by their sides. If we pay close attention to the length of each side of a triangle, we can see that there's 3 possibilities. First of all, if all 3 sides of a triangle are exactly the same length, then we call it an equilateral triangle. It's kind of a long word, but it's easy to remember because it sounds like it has the word equal in it. To see the second possibility, let's take the top vertice of our equilateral triangle and move it up like this. See what happened? 2 of the triangle's sides got stretched by the same amount, but the bottom side remained the same. Now we have a triangle that has only 2 equal sides, and that's called an isosceles triangle. That's a long word too. The best way to remember that is to look at an isosceles triangle and say its name 20 times as fast as you can. And finally, to see the third possibility, let's move that same top vertice again, but this time to the left. Now, all the sides are different lengths. This type of triangle is called a scalene triangle. So those are the 3 possibilities when classifying triangles by their sides. Equilateral triangles have 3 equal sides. Isosceles triangles have only 2 equal sides. And scalene triangles have no equal sides. That way was pretty easy too. The hardest part is just remembering the names. And now that you know both ways to classify triangles, let's see how you can use them together. Yep, you can use them both at the same time. If you classify triangles both by their angles and by their sides, it turns out that there's several possible combinations. To see what I mean, let's list the 3 classifications by sides: scalene, isosceles, and equilateral. and the three classifications by angle: right, acute, and obtuse. A scalene triangle can also be a right triangle, like this one. And a scalene triangle can also be either an obtuse or an acute triangle. In the same way, an isosceles triangle can also be acute, like this one, or obtuse, like this one. And in one special case, an isosceles triangle can also be a right triangle, like so. But things are different when it comes to an equilateral triangle. An equilateral triangle is always an acute triangle. Because all three sides are exactly the same, all three angles must also be exactly the same. And since we can't have more than one right angle in a triangle, or more than one obtuse angle, all the angles in an equilateral triangle must be acute. Okay, now that you know all about how triangles are classified, let's learn one more really important thing about triangles. In our video about angles and degrees, we learned that we can measure angles and say how big or how small they are using special units called degrees. Well, since triangles are always made up of three angles, each of those angles has its own measurement in degrees. And the important thing is that those three angle measurements, if you combine them, they will always add up to 180 degrees. For example, have a look at this triangle. If we were to take a saw and cut it up into three separate angles, and then if we were to take those three angles and rearrange them so that they're right next to each other like this, you can see that the total would be the same as a straight angle. That's 180 degrees. And this will work no matter what type of triangle it is. Knowing that a triangle's angles will always add up to 180 degrees can really help you out when solving geometry problems. There's a whole lot of situations where you'll know what two of the angles are, but you need to figure out what the third angle is, like in this problem. With this triangle, we're told that one of the angles is 35 degrees and the other is 45 degrees, but the third angle is unknown. We need to figure out what it is. Since we know that the total must be 180 degrees, we can just add up the angles that we do know, and then we subtract that from 180 degrees to see what's left over. The leftover amount must be the measurement of the unknown angle. So, 35 plus 45 equals 80 degrees. And when we take that 80 and subtract it from 180, we get 100 degrees left over. That means that our unknown angle is 100 degrees. And you can always check your answer by adding up all the angles to make sure you get 180. So you can see why it's so important to know that a triangle's angles add up to 180 degrees.
All right, guys. So I paused the video there. That was just a little bit of extra information about triangles and the measurements of their angles in terms of degrees. That is something probably next year in 4th grade, certainly 5th grade, that you'll get into. Our focus is just learning the different types of triangles and how they can be classified based on the lengths of their sides or on their angles. All right, guys, thanks for tuning in with me for math. Look out for another math video tomorrow. Anything you want to say?
Bye.
Bye.